And we are live. Welcome everyone to the next episode of Tech Excellence Meetup. And today we're going to talk about TDD and LLM by Tim Ottinger, aka Agile Otter. We are Tech Excellence. Our vision is to raise the bar of technical excellence across the world. Here you can see our teams, and Oliver and me are the hosts today. And of course, you can join us on meetup.com/tech excellence, and you can also follow us on YouTube, LinkedIn, X, Twitter, GitHub, and we also have a Discord community. Huge thanks to our sponsors, Optivem, Mocha IT, and CodeArtify, and to our partners, QE Unit. And yes, welcome, Tim. Just 1 second, I have to remove this. Yeah, so welcome, Tim. We are very happy to have you. Let me introduce you briefly. So Tim Ottinger, he's a senior consultant in industrial logic.
Not anymore.
All right, I got
as
it
of
from
August.
Okay, all right. I got it from LinkedIn, so maybe over there.
Yeah,
maybe,
it used to be true.
Okay, all right. Yes, sorry for that. Yes, so there's the next. He has been writing production software since 1979 and have spent the past 40 plus years evolving alongside the industry from early system programming to modern agile development. He's also co-author of the Clean Code, the famous Clean Code book, and the Agile in a Flash book, and a long-time contributor to the software community through writing, speaking, and coaching. And his mission is to help teams build better software and grow into high-performing, self-improving units. So, Tim, again, welcome. We are very happy to have you. And before I hand over the microphone, I would like to remind the audience that if you have any questions to Tim, do not hesitate to ask it in the chat section of YouTube. And at the end, we are going to spend time on Q&A. So again, do not hesitate. If you have any questions, just put it in the comment section of YouTube. So Tim, again, welcome. The microphone is yours. Good luck.
All right, thank you. So I decided to make the title of this a little bit more ridiculous. So you see it's TDD, LLMs, trunk-based development, TBD, and we're going to do it pretty darn quick, okay? And let's dive in and see what it looks like. So I'm an old extreme programming guy from the 2000s. I think I got involved with on Usenet with the group that was going to become the extreme programming group, probably around 97, 98. So I've been around for a long time. I was the guy who didn't go to Snowbird when they wrote the Agile Manifesto. I was invited, but I didn't go because I don't ski. If I knew then what I know now. So a few things that we've learned are pretty important and very helpful for getting software done in a safe way. I've outlined here, this is from my industrial logic days. I just borrowed my slides. They won't mind, I'm sure. But the process is basically these 5 primary elements. So the clean start is the beginning. You can go to the blog at Industrial Logic to get detail. They'll be happy for the traffic. The first part is, before you do anything, you put your system into a known, valid, clean state. All right. And a lot of people, I thought everyone did this, and I found out later on that that's not true. I was a little shocked. So what does that mean? It means that you have no uncommitted files in your workspace. It means you don't have any junk files in your workspace. Everything there is either committed or ignored already. It is that your tests all run clean, right? So you've pulled the code from the current branch. We tend to do trunk-based development, so we all pull from the main. We do a pull-R because we like rebasing. You may not. You may like a bunch of merges in your history. I don't know. But however you do it, you are current, the tests pass, and there are no leftovers in your workspace. So you're really ready to do anything. If you always go to this state before doing code, we find that we can move more fluently. And also, of course, anytime you pull or merge down, you should always run the tests because you don't know if you've inherited a problem unless you run the tests. So that's the first step. And I have scripts we'll see today called Clean Start. Easy recovery is more of a practice. When you're playing a video game and you get ready to go into a boss fight, you save your game. That's just smart. Well, it's the same thing, Git and all the other distributed version control systems. They still exist, right? There's still others. Oh, anyway, whatever they are, allow you to do commits locally without pushing. So you could just save your game locally. I've made so many changes. This next part might go wrong. I'm going to commit locally first, and then I'll move on. Whether you squash or not, it's a religious issue. I don't want to go into that. I tend not to. I like my history, but you do what you do. So the idea of saving your game is, of course, you can do a git reset -- hard, and then a git clean, and it'll take you right back to where you were when you did your commit last time. So you can always go back to when everything was okay. And Josh Karyevsky calls that a safe retreat. You might enjoy being able to do that instead of getting into a hairball and just getting tangled and lost. You remember that feeling when you just absolutely have to press on and solve it, because if you reset, you're going to lose 3 days worth of work? I don't remember that anymore. It's been that long. Fast feedback is making sure we know that the work we're doing is important and that we're doing it well. So how do I know I'm doing it well? All the tests still pass, including the new tests. If the old tests break, then I've probably done something not so good. So we work that way. Also, fast feedback is pushing code to a staging or production environment frequently. In trunk-based, often we'll push 12 times a day. It's not unusual. Of course, all the tests are passing for us to push. And of course, there's a CI server in the way to make sure that we don't push broken things. This is pretty important, but also teaming, which would be mob programming, pair programming, all the rest. We find out that, when we start to make a mistake and we have people watching with us and joining with us and taking turns at the keyboard, we'll spot mistakes a lot sooner. In fact, even the early studies from Kessler and Williams, I've got a name opposite of what it says on the book. Even in the early studies using grad students and doing it in classes, they found that this typically reduced defects by 20 or 30% and doesn't cost much more time considering what you get out of it. So it's a kind of a fast feedback that helps you get rid of mistakes before they become problems. The next stage along the way is the easy integration. And this is a problem of scale, right? When it's just me working on my pet project, everything I do is integrated because I have the main plus my current work, and then I push, I'm done. When I'm working in a company with dozens, hundreds, or thousands of other programmers, they may have made many changes since the last time I pulled. So easy integration means that we need to do CI. We need to integrate early and often. So whenever I've reached a good point where all the tests are running green, I can do another prepare that pulls all the changes, runs all the tests. And as soon as possible, I find out if we're doing things that are incompatible. And you know what? It will happen from time to time. As you practice actually continuously integrating, you find it happens more and more seldom, unless somebody new comes in and starts making crazy changes. So easy integration is important. And the more often you do it, the easier it is to do because you integrate small bites. The other piece of this would be the safe release, which is pretty much a consequence of the first 4 steps plus automated releases. And of course, everybody has GitHub Actions and what have you. Everybody's going to Kubernetes or to AWS containers, what it may be. If your release is automated and you know that the thing you're releasing is good, and you've managed to version your APIs well, then you tend to have pretty reliable releases, and it's easy to write tests around those. I have noticed that it's almost impossible to get to safe releases without the first 4 steps in place. It's always hazardous. It takes a lot of personal dedication and discipline if you don't have basic practices in place. So that's fine. Here's some examples of what we do. I have some start files, and I usually create an MD file. Okay. I usually have the LLM write me a contributing file or a README file that explains these. So one of the scripts is going to be prepare or clean start. I'm more frequently calling it clean start these days. We used to always call it prepare. One called run tests, although in Python projects, PyTest is just as easy. Fix up is a script that we have that runs certain cleanups, and run is what we use if it's not obvious how to run the project. Think about like when you have a back end and a front end and extra services, a run script starts everything. And when you close the run script, when you kill it, it shuts everything down. So here's some very simple versions. Here's a clean start or prepare. I'll give you a moment to look at it. So if you're a Bash programmer, I mean, it's such a short script, but set-e means if something fails along the way, it exits. It doesn't continue to the bottom. So it does the rebase. If there's any uncommitted changes, it stops. So you get a chance to take care of your stuff. UV sync. I'm running ultraviolet for all my projects. That's basically rebuilding my virtual environment according to the current set of the PyProject file. It's node dependencies and node locks, the whole thing. UV run PyTest runs the tests. And then, of course, if all of that works, one other thing I'll do is if I have a new pre-commit hook, then I copy it over into my Git environment. This is a way that friends and I can share our pre-commit hooks so we can edit them, and the next person gets it when they pull. And I have it usually print. I deleted the print statement so you can see when it's been syncing that. It's a pretty easy thing to do. Run tests often looks like this. So PyTest runs all my unit tests. Rough, of course, checks style, formatting, all of those things. Black is purely a formatter. It runs with the check option on. PyLint, I also sometimes use just to find duplicate code, which, by the way, you'll probably want to do this. LLMs repeat themselves. And then Bandit, of course, is checking security things. The fix-up script is not too different. Again, it's running rough, but letting it fix things. It runs black and lets it reformat the file. And then because you have to be a little brave for this one, there's a find command here that runs PyUpgrade. And PyUpgrade will rewrite bits and pieces of your code to make it current to the Python 3.10 standard. We're at 3.14 now, so that's not too new, and I pretty much fall into it anyway. So those are what the scripts look like. And, the way we use them, it's, they're just ways of keeping it easy to keep the code quality up as we work. I tend to find if people have high quality at their code at their desk, they're checking things and doing a good job with that, they tend to flow pretty quick to production. Whenever we hurry and cram to get through the code so we can push it and get the next ticket started, those things have a tendency to come back on us. Often, I've found teams where 80-90% of the work is floating around in queues between reviews and repairs and retests and things. Most of us could go a lot faster if we just spent the time to get things right to begin with. All of the scripts you saw could be written by hand. I've written them by hand for a long time. Nowadays, I tend to copy them in or regenerate them. If you switch between languages and projects, it'd be nice to have the same named scripts doing the things that are appropriate for the different projects. It'd be nice to download something, run the onboard script to set yourself up, run the clean start, run the run script, run the test script. And it lets you more fluently move between your projects and then deal with the details once you're in there. What's it got to do with LLM? Well, again, we have to watch them. They just do things. They have tendencies. A guy once told me you should never anthropomorphize an inanimate object because they really hate that. So let's get into the TDD side. We'll zip through this pretty quick. But notice we have a prepare box here, and we'll talk about the things we're doing. This is really, it's not different from the way we've done it all along. The thing with TDD is now we're going to use LLMs to do some of the code generation. They'll write some of the tests and they'll write some of the code. I tend to not let them write the commits. So we're going to do some of that. And I thought I'd make sure we understand. Typically, there's a picture people show. It's red, green, refactored, 3 boxes, and it's a circle. And that's a really good training mechanism. It's really simplified so anyone can understand it. We tended to use at Industrial Logic red, green, refactor, integrate, where integration is about committing what you have, pulling the new stuff, run the test, commit, push. That makes it sound really strict. And I wanted to make sure you had a picture that let you know that it's not as strict as you hear, right? So we'll begin with a prepare. I'll run the prepare script. By the way, I add a git clean into my prepare script. So it deletes files that, or at least tells me it's going to delete files if I did not add them. So I don't actually like to lose work, but I like to know if there's something that didn't actually get committed. So the prepare script I'll tend to do first, always. And I may do it several times during the course of a TDD whenever I want to integrate. So once I do that, of course, I can refactor if there's already existing code in order to get it ready to receive new functionality. From there, I would need to write a new test. After I've run the test to make sure everything is clear, I write a new test that fails. There is a cheeky shortcut. So if you're starting with a greenfield project, you can just jump right through your first test. You don't have to go through a bunch of extra steps. Okay, well, once we get a test in there and we run the test, it'll turn red because it failed, because the code doesn't exist yet. That's a good thing. That's where we should be. So when it's red, you only have one job, and that's to make it pass. That's probably the only part of this that is without options. That red arrow is exactly what it is. When it's red, you must fix it, no matter how it got there. Okay, so we get there, we come back. Suddenly we have options. We're at this run test stage, right? And it's like at the center of everything, right? So I could go back and refactor some more. I can refactor the tests and the code and run the tests in between. If it ever goes red, I'm back here again. I have to fix it before I can do anything else. But that is an option. This really helps us manage our cognitive load. I know it sounds crazy. You're like, oh, there's a billion other things I want to do. Yes, but if you've done 7 things, you don't know which one failed. So you need to kind of control your urges a bit. What's another option? I could, instead of going to refactor, I could go to commit, save my game, prepare, start from scratch on the next piece of my project. That's a perfectly valid possibility. Or having fixed one test and refactored, I could go do another test. Whenever the tests run green, we have all of these options: refactor, commit, new test, code. Do you ever go straight to code? Normally you shouldn't. But you know what? There are some times you'll reach a point where it's in some kind of an integration and you don't know how not to. But we'll talk about that as we go on. This isn't to constrain you. This is to help you, right? So this is a very simple decision-making system. It's pretty reliable. It has options. There's a lot of forgiveness. I do like the option, commit, prepare, come back around. I tend to find that the more often we get to the point where we could do anything, the better. G. Hill, if you know Mike Hill, you can probably find his work online. He talks about going from a ready state to the next ready state as often and quickly as possible. Well, the ready state is your tests have been green and you've committed, so you've saved your game. From here, you could do anything. You can push, you can come back around and refactor, you could do just anything. So from this state, you're ready. How long does it take you to get back into the state again? That's going to define some productivity for you. It's going to make a difference. By the way, there are some cheeky shortcuts. I've done a commit. I could sneak back to refactor, and I will. Sometimes I'll commit because it works, and then I'll come back and refactor. And when that works, then I'll commit again, and then maybe I'll come back and refactor some more. I can run loops between commit and refactor sometimes. Or, because everything works and it's been committed, I could go right to my next new test. And nobody would stop me, and nobody would call me a cheater or a thief for having done so. Again, this isn't to constrain us. It's to help us move forward in very decisive steps. And yeah, the process is pretty well dominated by the run tests. That's what it's for. So people are like, Tim, you've been, an old XPer for a long time. You've been teaching XP and TDD. Why are you talking about flexibility? And I have to say, there's a reason, right? If I write a test first, then as I write my new implementation, I'm already covered by tests and can immediately start refactoring, and the code I write will be testable because I wrote it for a test. So I'm in this TDD situation. If I don't write my test first, that's still okay. You don't go to hell for this. It's still okay. I could write some code first. But now when I go to refactor that, I'm not covered by tests. So I need to write tests for the code that I have that I think already works. That is a legacy code situation. The things that makes legacy code hard is you step in and you want to make changes. You believe the code works. It doesn't really have tests. You have to be really careful because if you don't do the right thing, you'll break something and not know about it, right? So I like to have a test first. And probably 85, 90% of the time, I have a test first. But sometimes I'm not sure how to do that. And I do some exploratory stuff, and then I write the tests. Now, if you're coming here so I can tell everybody you have to do it a certain way or else, bad things will happen, I'm sorry to disappoint you. And there's been some studies. And so some of the questions are, can you write the tests after or instead of before? And you can. What seems to work badly is writing all the tests and then going and writing all the code. That tends to go badly because it's just a hard way to go. It's hard to imagine what you're going to need and get all your tests right to begin with. You can do it, but then when you write the code, you tend to skip refactoring steps and you may not commit as often. It's the batching is a problem. What also doesn't work is write all of your code and then write all of the tests for it. And that I've never seen that work because you've got code, you think it works. You've got another ticket you got to work on or another feature you've got to work on or another bug to solve. So you're under a time crunch, and in the middle, you're supposed to be disciplined and write all the tests that are necessary and make sure they all work and that they read well and that the code is refactored so that the tests are easy to write. And really, you're going to do that when you've got these other things looming over you ready to go? You probably won't. So the pressure of everyday life tends to make writing all the tests last a losing proposition. And typically people will write enough tests to get the coverage number up. Worst reason to write a test. And then skip out into the next job. So the benefits seem to come from short, frequent cycles. And that's what this is, by the way, is an image taken from the AI tool Consensus, which is trained to serve up peer reviewed academic papers. So try it out. It's fun. They gave me a graph, So are the benefits dependent on writing tests before code, or do they also occur if tests and code are written in close succession? Yes, 71%, they still occur if they're just done in tight loops, possibly 0, mixed 14%. No, that's not how it works for 14%. So it's not a unanimous thing. It's not proven that you absolutely have to write your test first. But it does seem that if your tests and code are written in a tight loop, it has a huge benefit for getting things to work and keep them working. And again, errors are a major cause of backflow in work, so we try to avoid those. So I have some source code. It's not great. There's a repo, and I want to do some analysis on it. I'd like to maybe figure out, how to measure some things. So there are already tools for this, by the way. I've written some. I'll eventually publish them for free. I'm still playing with them. Adam Thornhill has done stuff with code thrash. We're going to play with that idea a bit and do some TDD. Maybe it'll be fun. I could bring up my context file. Let me see. I think I have. If I come over here. Let me get that out of the way. All we need is that. This is a little bit of a process file. It's not a very big one. Test first development, write tests before implementing, make small changes, run tests after every change. No commits without passing tests. I actually use a pre-commit hook for that. Red, green refactor, how to run the tests. Commit guidelines, tests must pass, small batches, conventional commits. If you don't know what those are, conventionalcommit.org, I think, will tell you. I like those because I do analysis on my repos. Concise messages. The LLM will never issue a commit statement. Commits are made by the human developer. Don't give up that right. You need to save your game, and you need to not have them mess with your stack of changes. When to reset, test configurations, pre-commit checklists, various commands, direct commands, and a typical workflow. And then, of course, some ANSI patterns at the bottom. This has been helpful with my LLMs. They don't always stick to all the rules and read all the context, but having one of these handy seems to help. Give it a shot, see what you think. But we want to do one. It's one thing to talk about it, it's a different one to do it. So I am in this project. It's not fully configured. Hold on just a moment. I have to tell it that this is my test sources root. And this is also, I just created this repo. So it's not done anything before. So right click, there aren't any tests. Oh, look at that, mark directory. Try it again. Test sources root. Run the Python tests. It should fail because there are no tests. It's a good reason to fail. One of the things I like to do is have it automatically run the tests whenever the code changes. So I've made that edit already. So main.py is junk. Hello from live coding at TE. So let's pop up an LLM and see if we can't get him to go to work. There are some things we may need to do first. So I have chosen that this will be done with, they have a command line utility tool called Typer. I'm going to use that. Let's see, we got PyTest. Is there anything else? Oh, get Python. I'm going to use get Python to access the Python environment, not Python, the Git environment, and read commits. Okay, UV is very, very fast. So let's start with the Juni Pro coding agent. Let's say replace main with a typer script. I need to tell it some things about this. There are no subcommands. It's just going to do one thing alone. That's probably good to start with. Let's start there. It'll take him a moment. One of my fears, I was telling the other presenters today, is that I may run out of tokens in the middle of doing this. The other fear is, of course, that nothing ever happens the same way twice when you're working with LLMs. So we'll see what it does to us this time. This one isn't super fast, but here we go. Let me get rid of this. There we go. Here's my main routine. It imports typer, echoes hello from live coding. If you want to see it, down here it said hello. Oh, done. Changed files, converted these things. But did the tests run? No, there are no tests, and nothing ran. So we're really not in a very good situation. Let's not roll back. Let's start a new task. So I'm going to want to tell it to open a Git repo. So we are going to need one parameter, which is a path, file path, path to a Git repo. In anticipation, I like to write this. I found this actually helpful. Of that, write a failing PyTest. If I just say write a test, it'll choose whatever it wants to choose. That expects an error if no parameter is given. That doesn't seem like a lot of information, but let's give it a shot. This will take just a moment. I'll close all of the windows I don't need, all the tabs. When I use Warp 2 is pretty darn fast, and it can generate a test a bit faster than this one can. But this is the one I've been using, and I'm going to try to stick with it for a little while because you see everything at once. Could I have done this myself? Yes, I could. So why would I ever do this? Well, partly because we're talking about LLMs and TDD. So partly of its demo, but also sometimes in an environment, I don't know how to write the first test. There are odd specific bits and pieces, right, to writing a test. You need to know the test environment. You need to know the particular test runners and things. And sometimes it's good to have those things provided for me. So there is a test main, which normally it creates a test directory and puts a test in there. Let's take a look at this and see what we've got in there. So app, it goes and gets the main command. Nice. It uses a CLI runner, which is good. The first time I did this, it decided to shell out and then capture the output, which was much slower. It invokes the app. It expects the exit code to not be 0. Okay, well, let's see, does the test pass? So let's pop back down to the test window. My keystrokes have been eaten up by other apps. There we go. And there is no add completion. Where's the add completion? That's an odd thing. Let's take a quick look. So we get the command, invoke the app. So I don't think that we need all this description, by the way. I think that the test is more straightforward. What did I cut out? Did I cut out something more than I needed to? No, that seems right. Okay, that's just where it failed. Well, this time, just to be obnoxious, notice we have this in 2 warnings. Well, I don't want to get distracted. Let's stay with Junie for just a minute longer. Let's say implement the code that passes this test. I'm staying inside the current task, just one more command. You'll notice that it always wants to put all these comments, paragraph marker comments. I need to tell it not to do that at some point. So it's editing in main. Oh, look. Main now takes an argument. Nice. Do the test pass yet? It's still working. It ought to run those tests automatically. That's interesting. Usually at this point, it works beautifully. It is doing the right thing here. It's just doing an echo. It does have an argument. Oh, but it has a default. I want it to not have a default. But that's not the problem. It has a syntax. Function has no attribute add completion. Yes. So I'm going to let it solve this one. I've done this 3 or 4 times in the past day and a half. So like I said, with an LLM, it's not deterministic. You'll get weirdness. Where does the add completion typer instance? That is clearly inside the get command call that so typer is expecting something we don't have. Now I've told it they can always run PyTest. So it's not asking me for permission. And we give another minute. Somebody said they really liked the idea of doing the work where you can sit back and drink a cup of coffee and wait for it to finish your stuff. I get the periodic sip of tea. And it's making adjustments. And it's rerunning the test. Same problem. We might get into a death loop here. If so, I'll have to stop it. One time it went and decided that the problem was it needed to rename main, which of course made no difference at all. So in the middle of this, again, this whole function, by the way, I have examples of it that are fairly short of doing the entire function. I just wanted to make sure we got this up, and it still fails. And that's because they made it they gave it a default. And I think I did last time tell it that there was to be no default on the parameter. So let me stop it. So it should be a positional parameter with no default. And again, we're still inside the same situation, so this should fix it. When we looked at main, I think I had mentioned that earlier. Oh, look, it made a default. Oh, why is there an additional function? It made it worse. Oh, the import. It's over here. The main. Oh, it just rewrote it. Still failing. That's funny. Well, here's where we can kill it and start over. I'm going to stop, roll back all. Oh, popped up on a different window. Sorry about that, folks. I mentioned that every time we do it, it does different things. And sometimes I think it's because I have slightly different prompts. I don't remember the last prompt perfectly, but I think a lot of times it's a different problem entirely. There we go. Now I can see you. So I'm back to having a typer. And do I have anything else going on at all? There is no test. So start again. So we need a positional, non-optional prompt for the script, which must be a path to a repository, a Git repository. In anticipation, write a test that expects that calling main with no parameter will fail. Well, I expect it to be about 10 times further than this by now. It's, again, it's different every time. The good news is we have control of it. Hopefully, if this works, we'll get the next several steps in just pop, pop, pop. It's also acting a bit sluggish for some reason, which maybe I'm in the middle of heavy usage in the East Coast or something. Okay, let's see what it looks like now. Oh, look, now it has a test folder. And see it's doing the sub-process run. Well, once it passes, again, with the red test, you have only one thing you can do, right? So it says that it expected to not exit with a 0, but it did exit with a 0. So implement the change in main.py that will cause this test to pass. So could these have been done faster by hand? Yeah, I think so at this point, which is also, I think, an important thing to realize. People talk about, oh, we need to use more AI. AI is going to speed us up so much. It's going to be so fast. It'll generate all the code. It'll be great. Even now, working in relatively small steps, you can see that such a thing as write this test apparently is very dependent on the state of the LLM and the, whatever else. Oh, look, we have a nice passing test. Cool. Well, if we have a passing test, according to our little diagram from earlier, we have a bunch of choices we could make. We could decide to really quick commit before something else happens. We could start refactoring. We could write a new test. Let's, just for now, you and I, let's do a quick commit. So we can do that this way. I can say, add these things and add that. Commit would be a feature, expects file path as parameter. Let's commit that one. I can't push. There's no place to push. Oh, it failed. Why would it have failed? Well, that's a good question. So check it. It reformatted it. There's a reformatter built into that. So let's try it again. Commit that puppy. And that time it worked. We could push now, but let's take a quick look and see if we want to get some refactoring in. So a lot of times we would do these things and it would become, tedious to generate a lot of data, but we might have a tool do it for us. I'm not crazy about the way this works. I also don't think I need all of this. That's a refactoring. Don't think we need all of this. We can see that it's an assert. It isn't asking much. Pretty simple. Let's amend that. That's fine. Okay, turns off automatically, which is good. Our tests are still running. Yes. Let's take a look at main. What did they do? Main has a repo path. It's an argument. Required positional argument. They're okay, readable, true, blah, blah, blah. Let's move on and do another piece while we get a chance. So let's pop in here and say, okay, new task. New task is important because it saves all your context until you say it's a new task. So you burn a lot of tokens if you don't do new task. So we have committed. So we're currently green and we've committed. That's good to have in mind. Okay, the directory passed to the function, to the program, must be a valid Git repository so that we can open it with git.repo in anticipation. We'll do two functions. Oh no, oh, I said function, stop. Let's recall that. Nope, can't recall. Okay, I've asked it for a failing PyTest. Me wanting to hurry has nothing to do with it hurrying. It is fairly transparent. It tells you what it's doing. So testing a non-repo directory is a failing test. Kick Junie out of the way. I don't need to see the project right now. There we go. So what happens? It takes a temporary path, which is a fixture in PyTest, creates a directory. I don't know why it created that. And it runs with that and it fails because it did not get a non-zero. That's great. Okay, let's move into this one. Oh. Okay. Yes, you did that. Come on. I thought you were finished. Oh, I said positive and negative test. So it's going to do the positive test also. Maybe. Okay. So one of the things you have to watch for in these is sometimes they'll actually re-implement a function inside the test file for it to test. So you have to keep it honest by double checking. So write the code in main.py that makes this test pass. and it's gathering its data. Notice that every single one of those, he isn't really understanding the project. He doesn't know his way around. I say, never anthropomorphize inanimate objects. These are all one-off tasks as far as an LLM is concerned. It's not working on a corpus of code and on a code base. It's doing a task after another task. The good news is these tasks that generate are fractional credits, small numbers of tokens. If you actually have it do something big, it will consume them like nobody's business, possibly even hundreds or thousands of them in a minute. So it's taking a look. It's going to be playing with MainPy. Let's go take a look at that one. Oh, and look, test passing. So the outputs for a typer project it's using repo to open it. Use an echo or an S echo to print from typer, and that works out pretty well. Well, now we have a passing test. So looking at our earlier diagram, I could write another test. I could refactor. I could commit. I could potentially write new code, but I don't want to do that. So let's take a look at how it implemented this in main. So it has this big thing with try, repo, blah, 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 typer. I'm going to do a little bit of a mean thing. I'm going to mess with it just a second. Repo equal repo, which is a repo, equals none. And then I'm going to set repo equal. And now we're not using that repo, which is going to get flagged as an error when we run the linter, but that's okay. The reason I did this is so that I can extract this block of code and it will keep it around as returning the repo. So I'm going to save this as a method. Come back here. Wow, that's interesting. For some reason or other, something's taken over my control. There we go. We're going to call that open repo. And some of you say get opened repo. I'm not going to fight with that right now. Let's go. So open repo should return. Oh, look, it doesn't. It doesn't. That's interesting. Well, I want it to. That's a really bad extraction. It's just a little bit of a change. I don't need the open repo, but I'm getting it. And that seems to actually be happening and all the tests are passing. I like how we've started. The code's a little bit tidier. It still just echoes. So we're going to have to get into more interesting stuff. Let's see how much time we have. It's a little tight. So let's do this. Let's save our game. Main and the test. That's all we've got. Oh, so we're getting close to, oh, look at that. Oh, the unused variable complaint. I told you we were going to get that. Okay, clean start. We can do anything we want at this moment. So what I'm going to do is I'm going to have it add something real quick that actually does a thing. So I'm going to say, is there a new, yes, new task. Okay, we will need to gather information from the repository into data structures. The structure will be the file name and a list of the commit messages for every commit that includes that file. In anticipation of this, write a test. I'm calling the new function with only one file in one commit. Eventually, I'm just going to have a whole bunch of these written down as templates, and I'll type, copy them over and then change the couple words I mean, or I'll write a program that does this for me. We'll see. I do like guiding it this way, but a lot of times I just like to write the tests myself, or I just want to write the code myself. I'm not always happy with its choices. I'm going to bet that it's going to use some really primitive data structures, and then I'll have to step in and suggest to it that it uses actual library functions and things to make it tidier. So test repo summary, single file, single commit. Test file was generated somewhere over here. There should be a failing test. There is. So there is no such file. Okay. The function, but implement nothing. Why am I doing that? Well, I would like to have a better failure. I don't like the way it's failing. It's not meaningful to me. So over here in main, we should get a new function appearing that does next to nothing. No. Oh, a new Python file was created. No. Okay, stop. Come here, you. Wow, it's not behaving now. Well, that's done something new. Well, I told you it's never quite the same way twice. Here we go. So new structure will be a file, will be the file name listed. Okay. So let me take a look at what it's done to my project. We may have to get rid of some. Yep, it created a repo summary. I did not want that. So we'll get rid of that in just a moment. Hopefully this time it will put it inside main.py. So I think I've mentioned, sometimes they're hard to control. This is the very, very first time it actually created a separate file for this function. Up until now, it's always been really good about adding it into main. So this is, by the way, why is it not more productive? Well, it's not very predictable. At this point, we probably could have written it faster ourselves, but it's still interesting to see how it fails and why it fails. And would you have known to do all of this? Well, I probably would have, but I'd have to look at the document because I don't usually use all of these flags, and I'm still not sure they're all valid. And I'm left with a situation where I can just leave it as it is, and learn nothing, or I can go look up all these different options, and I will look them up. I refer to this as doing Bill and Ted's homework. If you've watched Bill and Ted's Excellent Adventure, at the beginning, they're sitting at a gas station on the pavement. And as people walk by, they ask them the homework questions. And if they don't know, oh, well, then we'll ask somebody else. After a while, one of them looks at the other and says, we're not having much success here. Perhaps we should go to the Circle K, which is funny because that's another gas station. So it's pretty clear their strategy is don't learn anything, just go get people to give you answers. So let's see what it did. So let's go back to main. Is it here yet? No. That's interesting. It didn't do a thing. Okay. Let's get rid of this repo summary. Let's just delete it outright. I have to give it an OK. There we are. Create a function in main.py that satisfies the test. I said that first. Now I'm going to go take a look at the test. Yeah, that's kind of the wrong way to do it, but see what the test looks like. So this creates, oh, look at this. It actually creates a repository and it sets values. So there's initializing a repository. I might not have done this. I might have gone straight to mocks. So what's it do here? So it creates a repo, makes a directory, initializes a repo in that directory, creates a file. By the way, where does it do it? It uses temp path, which is a fixture that creates a temporary directory. It cleans it up after. So it creates the file and writes to it. I might not have done that. It adds that to the commit. It actually performs a commit on the repo using the API. So here's looking for gather file commits. It's going to pass a repo to it, and it's going to expect to get back this structure with hello text and the commit message from above. That's not too bad. So one of the things I found is helpful with the LLMs is if you're going to generate a lot of data. So if I want to make a whole bunch of commits in a repo, it will generate a new repo and it will happily produce, a dozen or 100 or 1,000 commits in the repo, which then we can read and write. What's nice about this is it's using a real repo and it is actually using commits. So it's actually using the API. It has control of the data for these tests. What's not so good about it is this is going to take longer than if it used mocks. But let's go with it for just a moment. So in main, has it happened? Has it happened yet? I don't see it happening. Where are you, Junie? Implemented gather file commits in main.py. There they are. Oh my goodness. It's a lot. Get rid of that. I don't need to have that. Don't need that. Oh, look, it's smart enough to use a default dictionary this time. I usually have to tell it to do that. Maybe something has gone into the training. So it walks through all the commits and it takes out the commit message and strips it. We'll probably want to intern that as well to save space. It takes a look at each one of the files that's in the commit stats. That's the right thing to do. And it is a dictionary, so the keys is correct. The file name is interesting. Why did they check out the base name? That's new. I don't think we need that. I think we just need the file path. Would it change anything if we did that? Oh, yeah. Oh, I see. Yeah, no, it doesn't need to do that. So that should fail a test, maybe. Tell me it's going to fail a test. Nope, it passes the test. Well, it's a very simple function. It has an unnecessary line in it. It had a whole bunch of unnecessary comments. It does a nice job. Okay, so one of the things I don't like is that what it returns is a primitive. And so we could, let's see what time. Oh, we're running too short on time. I would have it convert that into a named data type. So you can see from this that there were some issues, right? Everything's different. It always comes out differently. In over a half an hour, we've only gotten this far, but it's very close. The next step would be to sort that into the 10 most important ones and print them out with a formatted report. So it's not too awful. But the trick wasn't the program, right? The trick is the process. So you've seen me had to start over. You've seen some clean starts. You've seen early commits where we've had to roll back changes. Roll back as they get reset hard. So the only questions I have maybe for you is, what did you see that was interesting in this? What did you see that was discouraging? What might you try? What would you have done instead? And with that, I think I'll turn it over to our friends. How are we doing, Daniel and Olivier? Oliver.
Yeah. Thanks a lot. It was a great session. I really enjoyed it, especially because we've seen the two sides of the coins of LLMs. So one side, the positive side, it really helped you or helped us to really generate code in a domain we don't even know. It knows the documentation, all these things. But of course, the other side is that sometimes it made mistakes and things we didn't ask for. But I really like that we've seen all these processes you presented in your presentation, like, writing a failing test, make it pass, refactor, undo the things. So, recovery. So yeah, great job. And, great job that you did it on live. So you had the courage to do this with LLMs. So absolutely. And yeah, with a lot of people, and also the chat section went wide. A lot of people were talking about a lot of good things. So maybe it would be time to go through the questions and the comments.
Excellent.
Yeah. So first of all, we have this. She says, second edition of Clean Code out now, right? Otter. So what is your take on this? Is it out? Do you like it? Please tell us a bit.
So far, I've only read my chapter. I don't think I've read Jeff Langer's chapter yet. So I haven't actually seen it. I think I might receive a PDF of it for free by being a co-author, but it is out as of, I think, October. So take a look at it. I removed some things I hated from my chapter that had been added after I finished it last time. And also, by the way, I'm taking the same information that's there and I'm expanding it. I will have a mini book on LeanPub on naming probably sometime next year. I might put some previews out for all of you.
Cool. Yeah, looking forward. Personally, I haven't checked it out, but absolutely, those exciting stuff. Let's go for the next because we have a lot, and let's try to cover as many as possible. So from Urs, he asks, "What about?" So he asked this question during your presentation, not when you did the code. Okay, so when you had the slide sheet. So he asked, what about prevent integration problems through, for example, slicing, modularization, decoupling in addition? So when you talked about easy integration at the beginning, so what is your answer to this?
So absolutely, you're absolutely right. Those are important things. So here's an article. It's over on the Industrial Logic site. I know you can see me typing. So when we talked about easy integration, one of the things that we always talk about is that when we start, it tends to be pretty rough. And so team A is working on change, started with version A, team B worked with change, started version B, blah, blah, blah. And the likely to change. So one of the tricks that we learned, and I'm looking for the section where they talk about it. There you go, is reducing target size. So by breaking the code up into smaller slices of work, into better, more cohesive modules and services and things. And I was looking for the, there you go, modularity of design, use of interfaces can help to keep us from making changes that interact. when I do this with teams, sometimes I do a boot camp and I'll work with 20 some odd developers, and it'll be the first time they ever did trunk-based development, and it'll be the first time they've ever done CI. And on the first day, there's like not much going on, but maybe a CSS file and an HTML file when they start this work. And they're going to, build into it. And everybody's editing that same index HTML file. And by the end of the first day, they're really frustrated because every time they try to push, somebody else has a change they have to pull and push again. And then pretty shortly, they start to realize that if you can break up the app a little bit, then you can get it into pieces that you can change independently and survive with. And then, of course, if you have a common piece everybody leans on, that becomes an integration point where there's a target there that we keep hitting. So we start to split things smaller to reduce the target area, right, for the collisions. So there's a lot of stuff in here talking about, what we can do about that. But absolutely slicing the stories, modularizing the code, decoupling, huge ways of reducing the target area for collision. And it's highly favorable to do that. I don't know anyone who can survive without doing it. Great question.
Very nice one. Yeah, let's jump to the next one because we have still many. This is a very good one. I'm interested in your answer. So from Garrick, by the way, hey Garrick, let's see you. So did you sacrifice a rubber chicken to the LLM gods so that your queries find the right tokens?
Oh, that's what I did wrong. That's probably it.
You get it.
It's the wrong chicken.
Yeah.
I'm supposed to do the one without spots. A pure chicken. It is though a tough game. Every time I'm using the same intentionally today. I've been using the same LLM repeatedly, and every time the choices it makes have been different.
Yeah.
So I don't know how to find just the right tokens to make it behave. If we're looking for consistent good performance, I think we're looking, we're barking up the wrong tree.
Yeah, that's one of the main disadvantages of these LLMs, that they are non-deterministic. So they really produce different results even when the prompt are the same. So the prompt is the same, and that's my experience as well, that even if I with the same prompt, I try to run it 5 different times, it results in 5 completely different solutions. So it's up to me to decide which is the best one to pick. So yeah. All right. So related to this, there is a question. Wonder why Tim likes Juni. Would be interested to know how he came to select that tool. So the question is, why do you use this LLM? Why don't you use some other ones, or have you tried other ones? What is your use?
So it turns out I'm not really all that fond of it. It happens to be that I can stay in one screen. I have a 3-screen setup. So often quite a lot of the work I'm doing in Warp on one screen, PyCharm on the other, and then looking things up on the 3rd screen. But when I have to show it for a presentation, it's better that it's all in one place. I think I didn't show it to you, but over here I have Warp 2, which it selects whichever one of these it thinks will be get the best result with the fewest tokens burned. And it automatically chooses which model, and it's pretty darned quick. I've been very pleased with it. I've used it to kind of put together a lot of code, and it has this cool little pane on the side that will show you, here's where our commit is right now. Here's the things that haven't been committed and pushed. So it's kind of nice. It's a nice bit of awareness of the situation. On the other hand, this is in the same screen.
Yeah.
It's a presentation choice. Also, by the way, that's why you have white background. Everybody's like, ew, why are you in light mode? Well, it shows up better on the screen when you do a presentation. That's all. It's for you. It's because I love you all. That's why I do it.
Yeah, and also bugs don't like the light, huh?
Yeah.
So yeah, and then also related to this, Daniel says, I think that Juni uses an abstract syntax tree that JetBrains IDs keep in memory, which I imagine is pretty useful as context. So I'm not sure of this. I'm not sure whether you heard of it. So Juni might has an edge because of this.
Yeah, I think probably so. It's done some very nice things with completion and with refactoring.
Okay.
And by the way, the JetBrains tools are untouchable in the realm of refactoring. There's just nothing like them. But I think probably it does. And things like convert this primitive structure to a named data structure. It tends to do things like that very, very fluently and rather quickly.
Okay, promising. Yeah, so it has its power, surely, this Juni, since it's integrated in the ID.
Okay. By the way, I just want to show you real quick. There's I told, by the way, this inline one, he's not always great. Oh, and it just deleted it. Well, never mind. I'll show you later. I just asked it, show me 3 different ways you could have written this function.
Oh.
This is useful, by the way. This is actual performance enhancing drugs now, right? So show me 3 different ways you could have written this function. And it shows me those. And I look at those and it's like, you know what? I like the third one better than I like the way it used. Let's replace it, right? And I'm often doing this with algorithms. I'll say, show me 2 ways or 5 ways or 12 ways to do this. And it'll come up with a bunch of different things. And I'll go, oh, I would have done it this way, but that one is really obvious and clear and very concise. I really like that one. So use this to expand your learning.
Yeah, excellent ones to learn. Yeah, I agree. Okay, let's jump to the next one. We still have plenty. Paulo asks, do you get tired of the non-deterministic nature of LLMs? So how do you feel about it?
Boy, do I. I certainly do. Some people, that's the fun of them, but I'd rather just have tools that work sometimes. At the same time, you know, there are things, I learn different things when I see different code. So I do kind of enjoy, you know, the differences, but it is a nightmare for a presenter. I have no idea what I can get done in a half an hour because it could be all of it or none of it, depending on what kind of problems it causes itself. So yeah, it's frustrating. I think given concrete enough tasks, it can do a pretty good job, but you really have to watch it.
Yeah, true that. Also, there's another point related to this, that this lack of fast learning is what prevents it from being a true tool for human augmentation and uplift, as Doug Engelbart defines it. So here she refers to Juni, that it really cannot learn fast. Do you agree with this, Deepanto?
By the way, Fortune is the one that recommended, I think, Consensus and some of the other ones that I'm using now. I've started using some different tools because some of them actually aren't bad for a Perplexity. So Perplexity and Consensus, I think I got from Fortune as ways to expand the learning. But absolutely, one could use the LLMs just for de-skilling themselves, right? You figure it out, you solve the problem, you just write the answer, don't write any tests. How does it work? I don't know, but it ran on my machine and it looked good. You know, doing Bob and Ted's homework is a real problem. It needs to explain to us if it can, but it doesn't know why it chose what it did. It's not reasoning. So we have to do the extra work of learning.
Yeah, true that. Critical eyes are needed. Yeah. Reviewing code and testing the hell out of it. Absolutely. These are becoming the main tasks as a developer. Also before that, they were the main task, but now since LLMs are writing the code, we review mainly and test the hell out of it. Yeah. Another question from Paolo that he asked, do you suggest to use LLMs this way to develop new domain features in a big code base, not a legacy one, with unit test and integration test? So would you suggest it if you would need to consult it to a company or generally?
So don't you hate it when the answer is it's one of those it depends answers? So one of the things I did, not for features, but we had to, shine up an old Ruby web page. And so I had it, upgrading things and adjusting for them, so doing some upgrade tasks to use new versions of libraries or of the language. And that was pretty nice. And I've had it do some nice things with kind of reworking the CSS before. New features, yes and no. What it does well, by the way, if you're working in Angular, React, Svelte, whatever, have it generate a component and put it in, don't connect it to the app, just put it in Storybook, right? And then you can get the different versions. You can put tests against it, show it in the different states. You can really quickly start going through with people. This is what it could look like. What do you think? Regenerate it, do the same thing, but, right? That's really nice to develop the ideas for new features, I think. And then, of course, it burns tokens, but you can ask, what is the impact of doing this, right? What are the affected components further down the line? It doesn't do that very well, but if it's indexed the database and you've got a good one, it can start to give you some pretty good suggestions. Ultimately, we rely on human intelligence and good test suites, and if we don't, we're not ready for LLMs at all.
Totally agree. So even in the age of AI, tests remain the most important part of the projects, huh?
Yeah.
Always.
By the way, fun exercise. I've done this a couple times and then deleted the code and had it regenerate the code to pass the tests. Each time it generates a different app, right? It uses different names, different algorithms, different structure, but sometimes they're kind of interesting. Sometimes they're kind of good. So if you have the test, though, it will generate a working app. So I'm thinking, if I were in a situation where, we had this one section that we'd have no source code, nobody knows why it works the way it does. It's, been there for 50,000 years and it was written in an obscure dialect of Pascal. I could see using an LLM to write pin down tests, approval tests around it, and then produce new code that passes the same tests. And I don't know how expensive that would be. I imagine that would be, thousands of dollars per day to do it. But at the end of a week, you'd probably have something that you could really use. And in a language you like, maybe even in Rust.
Yeah, exactly. Yeah.
But the unit tests and integration tests to develop new features, absolutely in a big code base. Totally 100%. LLMs, not sure.
All right. You use this Juni, and do you know what kind of? So the question is, can someone tell me what the model is Juni using here? I guess we wanted to try to figure out at the beginning, right? And maybe its own model. I'm not sure. Maybe we can Google it.
Yeah, I don't know. I wonder if can it tell us?
It says that GPT-5. Yeah, they have default to GPT-5. I guess it's configurable. I assume usually for such such AI tools. And the GPT-5 is the sort of default for most of them. So
it's opening the README file to find out. No, I don't think it can tell me directly.
I guess GPT-5, but I mean that's no. I go quickly. Surely configurable. It must be configurable unless it is its own. But what I read is it's you can select it. It's configurable. So which is a good point. So
there is documentation. Yeah, Claude Sonnet. Let's see, Claude Sonnet 3.7 and 4 from Anthropic, Google Gemini 2.5 Pro. GPT-5, some third-party LLMs as needed.
Mm-hmm.
I have not hooked it up to my own context manager. I'm thinking about that. Maybe what I'll do next is start generating my own based on my own rules and my own code,
Yeah.
and see what I can do to try to make it much better. There's also an initiative. Agile Alliance has some people who are gathering together and trying to generate their own clients that will have their own, intelligence and be a bit more reliable. I don't know how that's going so far. I need to check in. I'm a member who hasn't been attending because I've been wrapped up in other things.
Mm-hmm. Yeah, that's interesting one. Would be nice to see or have a model which trained really on high quality code. So not only on bad, because these models have been trained on every kind of code it could find, on in the internet, GitHub, below quality, high quality. But would be nice to see an LLM which is trained only on high quality code. What would be the result? Or train it as a negative set, train it on low quality code as a negative set. It can be an interesting exercise as well. By the way, did you try to use any other LLM tools? So you mentioned this ROP, this.
Yeah, I've been using Warp probably more than anything else. It's very fast, and it gives pretty accurate results, and it's not as unrepeatable.
Okay.
It's more consistent and faster. And again, it chooses which model it wants to use to try to see how many tokens it burns. But I like it. By the way, a really fun thing for that was I had in one of the tools there were all these different checkers and reformatters and the IDE, and they were all doing it differently. So if you go in and hand edit something, the linter would kick it out as being misformatted, and then if you use the AI to do it, it would say it would change the formatting to another wrong way. And so I said, hey, on Warp, can you just take all of the reformatters and checkers and make them all work the same way? And of course, it did an editor config, and then it changed my project file where it was configured there also, and it put them all in harmony. And then I just didn't touch it for the rest of the project. So,
right.
Getting configuration files and making them all 80 characters instead of God knows what, all those things.
Yeah. All right. We are getting close to the end. There is one more question, a very good one. I think it could be excellent one to wrap it up. So the question is, do you anticipate the AI field replacing pure token prediction for coding agents anytime soon or at all? What's your opinion on the future of AI-assisted coding, if not? So in the next 1.5 minutes, briefly, if you could give us an answer, that would be appreciated. About what do you think about the future of AI-assisted coding? Do you see potential, not where we are going?
Well, not looking at the science of it, but looking at the market for it, I think they've generated a rather powerful appetite in the world for a more reliable tool. So I would be very surprised if in the near future we didn't see different kinds of non-LLM tools that are working off of better models. I think we'll see things get a lot better. I don't think the current path is going to be the only path. I think that there's a real market for better tools.
Awesome. So it's promising, and I agree with you. It's promising. The future is promising, and AI tools are here to stay. Definitely, we got to leverage it. Yeah. Well, team, thanks a lot. It was awesome. I think it was one of the first session. It was the first session where we do this TDD LLMs, and we went really, we dug really deep in this topic. So thanks a lot. Great job on this. And also that you took the courage to do this live coding, given the fact that these tools are non-deterministic. So every time so basically you could practice it, but you got still surprises. So that was a big plus. So thanks a lot. And thanks for Oliver as well. And of course, you can join us on Meetup and follow us on YouTube, LinkedIn, X, GitHub, and Discord. Huge thanks to our sponsors, Optivem, Mokaiten, Coderfy, and to our partners, QE Unit. And basically, this was our last Meetup this year. So thank you, everyone, for joining us through this year. And for next year, we already have great sessions planned. So stay tuned. And again, team, Thanks a lot, Oliver. Thanks a lot. And for the audience, the biggest thanks to you. So,
and everybody remember to enjoy the adventure.
Exactly. Yeah, thanks again. And I wish everyone a good day further. And see you in the next one. Bye-bye.